Now for the second video for the test review for chapter 14, let's start off with some calculations dealing with the KW expression. So one thing that we learned is that in any kind of aqueous solution that we're dealing with, if we take the concentration of hydronium and the concentration of hydroxide, if we multiply those together, okay, no matter where we are on the pH scale, then when we multiply those concentrations together, we get a constant. We get this 10 to the minus 14 value. Now, I'll just say this, there's a bunch of different ways to show this equation here. And I'm just going to go ahead and scribble that out, okay? This is my formula that I'm going to use to do these calculations. Now notice what this one's asking for. First off, I want to calculate hydronium. Yes, so I'll need to solve for that value. And then the other part is that I want to figure out whether this solution is acidic, basic, or neutral. And then that's where that equation is going to come into play, and then our knowledge of the pH scale. I will say, with practice, even knowing the hydroxide concentration, like in this example, this is going to be a basic solution. So with practice, just with the with the hydroxide or the hydronium concentrations given, a lot of times you can just determine what the acidity or basicity is. But I'm going to go through the full spiel, all right? And I'm just going to do A here. So I'm given hydroxide concentration. I want to determine hydronium, so I want to solve for hydronium. So my algebra here is going to look something like this. Why do I divide by hydronium? Well, I want to get rid of hydronium on this side. So hydronium concentration divided by hydronium concentration is here. Why do I divide by hydronium concentration on this side? Well, that's algebra, okay? Whenever you manipulate an expression, whatever mathematical operation you do on one side of the equation sign, you'll do the same mathematical operation on the other side. Now I have a new expression. Let me rewrite that. Okay, I'm ready to plug and chug. I'm given the hydronium concentration here. So if I divide the two numbers by each other, I get 6.7 times 10 to the minus 13. When you do this on your calculator, this portion of the formula, you're looking for your EE button. Most students are using text as instrument calculators, for good or bad. And so you'll be looking for an EE button somewhere on your calculator. That's typically the way this is done. There are some variations on that theme. I like to discourage the use of the multiplication sign and then like the caret to raise 10 to the minus 13. That doesn't work too well. Usually if a student tries to use something other than the EE, usually they're off by 10 or so in their final answer. But this is the concentration of hydronium, and then that's what we're going to plug into that portion of the expression. So I don't want to get into the full description here, just briefly. Okay, this pH scale, it's a log scale. So when you go from 1 to 2 to 3, you're not increasing by 1 or 2 or 3. You're increasing by 10, 20, 30 times the change in the hydronium concentration. The concentration of hydronium is usually pretty small, and they cover a really broad degree of concentrations. And so by taking the negative log of an expression, you take that really sort of broad expanse of numbers and you put them in a little bit more usable form as these whole numbers. But basically, the exponent that you see on the hydronium concentration is going to be close to the pH of the value there. And you see that for this problem. Let's do our plug and chug. So if I take the negative log of this number, I get 12.17. Again, like I said, this is a basic solution. That 10 to the minus 13 is a really, really small number. Remember, as this negative exponent gets or appears to get larger and larger, but with the negative sign in front of it actually getting smaller and smaller, minus 13, that's pretty small. That means the hydronium concentration is really low. That's characteristic of a basic solution. Let me just put one other little thing just to remind you. In a basic solution, concentration of hydronium is less than concentration of hydroxide. Or another way to say it, concentration of hydroxide is greater than the concentration of hydronium. But the only place where these two values are equal to each other is when the solution is neutral. I'll leave it at that for the second video. There'll be one more to follow up for this chapter, and that'll do it. Thanks.